since the sea is considered to be the largest water body on the earth, why is the water so salty that we can't drink it?
The seawater is so salty because it contains large amounts of dissolved salts.
Do we get the salt which we use in our food from the sea?
Yes, of course. Along with common salt, you can get other salts from the sea. Some salts are prepared in laboratories. This lesson is about the occurrence and uses of different salts. At the end of this lesson, you will be able to define salt, list the uses of sodium chloride, explain water of crystallization using an experiment, and list the uses of plaster of Paris. The product of an acid reacting with a base is salt and water. From this, we define salt as a compound formed by the reaction between an acid and a base. This reaction is called a neutralization reaction. For example, when an acid like hydrochloric acid reacts with sodium hydroxide, which is a base, sodium chloride, which is a salt, is formed.
Oh, salt which we use in our food?
Yes. Some salts like sodium chloride are edible, and other salts like magnesium chloride, potassium nitrate, zinc carbonate, and copper sulfate are useful to us.
Do these salts have any unique properties?
Salts are mostly solids and are ionic compounds. Every salt has a positively charged cation and negatively charged anion. For example, sodium chloride is made of sodium ions and chloride ions. Do you know how these salts get their name?
No idea.
Salts usually get their name from the acid which takes part in the reaction. Salts formed from any hydroxide and hydrochloric acid are chlorides. For example, potassium hydroxide reacts with hydrochloric acid to form a salt called potassium chloride. Similarly, salts formed from any hydroxide and sulfuric acid are called sulfates. For example, magnesium hydroxide reacts with sulfuric acid to form magnesium sulfate. Accordingly, salts formed from any hydroxide and nitric acid are known as nitrates. Ammonium hydroxide reacts with nitric acid to form the salt ammonium nitrate. Likewise, salts formed from any hydroxide and carbonic acid are carbonates. Sodium hydroxide reacts with carbonic acid to form the salt sodium carbonate. Based on the strength of the reacting acid and the base, salts can be classified into three types. Salts formed from strong acids and strong bases are called neutral salts. They have a pH value of 7. Consider salts such as sodium chloride and potassium sulfate, formed from strong acids like hydrochloric acid and sulfuric acid with strong bases like sodium hydroxide and potassium hydroxide. Salts formed from strong acids and weak bases are called acidic salts. They have a pH value less than 7. Consider the formation of salts like ammonium chloride and magnesium nitrate, which are formed from strong acids like hydrochloric acid and nitric acid with weak bases like ammonium hydroxide and magnesium hydroxide. On the other hand, salts formed from weak acids and strong bases are called basic salts with a pH value more than 7. Consider the salts like sodium carbonate and potassium acetate, which are obtained from weak acids like carbonic acid and acetic acid on reaction with strong bases like sodium hydroxide and potassium hydroxide.
Oh, it's too salty.
Seawater contains many dissolved salts like chloride of potassium, magnesium, iodides of potassium, etc. Although the most abundant sea salt is sodium chloride or common salt, sodium chloride is obtained from seawater by the process of evaporation.
Without common salt, food doesn't taste good.
Absolutely. Common salt is an important constituent of food and is referred to as table salt. Common salt enriches the flavor of food. It plays an important role in the functioning of our nervous system, the movement of muscles, and in the production of hydrochloric acid in our stomach. It is also used as preservative in pickles, fish, and meat. Sodium chloride is used in the manufacture of soaps. It is used to melt ice that forms on the roads in cold countries. Sodium chloride is used as raw material for the manufacturing of various other useful compounds like sodium hydroxide, sodium hydrogen carbonate, sodium carbonate, and bleaching powder.
What is sodium hydrogen carbonate?
Sodium hydrogen carbonate is produced when a concentrated solution of sodium chloride reacts with ammonia and carbon dioxide.
Is it useful to us in the same way as sodium chloride?
Yes, it is useful in many ways. One example would be that it is an important ingredient in baking.
Yes, I remember. My mother uses it in the kitchen while she bakes a cake, and she also says that it can even neutralize the acid produced in our stomach.
Baking powder is a mixture of baking soda and a mild edible acid called tartaric acid. Baking soda reacts with the hydrogen ion of tartaric acid and releases carbon dioxide, which bubbles out and helps to raise bread or cake in the process of baking. It is also used as an antacid because, being alkaline, it helps to neutralize the acid of the stomach. Apart from that, it is even used in soda acid fire extinguishers,
Which we usually come across, those in the multi-storied malls.
That's right. Do you know how glass is made?
No idea.
Sodium carbonate is used to manufacture glass.
Sodium carbonate?
Sodium carbonate is obtained by heating sodium hydrogen carbonate and is called anhydrous sodium carbonate or soda ash. The anhydrous sodium carbonate is dissolved in water and recrystallized to sodium carbonate decahydrate.
How is this sodium carbonate useful to us?
Sodium carbonate is used to manufacture cleansing agents, soap, glass, paper, etc. It is also used for removing the permanent hardness of water. It is used to remove the dissolved salts in the water and make the water clean for drinking. It is even used to manufacture sodium compounds like borax, which is used as a cleansing agent.
I love to play with water, but I feel my skin develops some itching sensation when I play in seawater. I wonder why it doesn't happen when I swim in a pool.
The microscopic organisms or small germs present in seawater irritate the skin, whereas the water in a pool is treated with bleaching agents like bleaching powder that kills insects and germs.
Bleaching powder?
Bleaching powder is chemically called as calcium oxychloride, which is obtained by passing chlorine gas through calcium hydroxide.
Great! What else is bleaching powder used for?
It is used to bleach cotton and linen textiles and to bleach wood pulp and even used in the manufacture of paper. Bleaching powder is used to disinfect drinking water and make the drinking water clean and safe. What does your mother do when the kitchen drain is blocked?
She uses a drain cleaner to clean the clog.
Did you know the drain cleaner contains sodium hydroxide, which cleans the clog formed in the drain? When the pipe is clogged, it is because of a combination of fats and grease. Cleaners that contain sodium hydroxide, either as a solid or already dissolved in water, converts the fats to soap, which dissolve in water. In addition, when sodium hydroxide dissolves in water, a great deal of heat is given off. This heat helps to melt the clog.
How can we obtain sodium hydroxide?
Sodium hydroxide is produced by the electrolysis of aqueous solution of sodium chloride called brine. The electrolysis of brine is called the chlor-alkali process, since the products formed are chlorine and an alkali. In the process of electrolysis of brine, hydrogen is collected at the cathode and chlorine at the anode. The hydrogen formed in this process is used to manufacture fuels, margarine, and ammonia for fertilizers. Chlorine is used for water treatment in swimming pools to manufacture chlorofluorocarbons, PVC, chemical compounds like chloroform, carbon tetrachloride, disinfectants, and pesticides.
What are the other uses of sodium hydroxide?
It is used to manufacture soaps and detergents. Sodium hydroxide is also used to manufacture paper, artificial fibers like rayon, and dyes.
Wow! Why is the sand shining?
Did you observe that it is crystalline? Similar to sand grains, salts also have a crystalline structure. Moreover, some salts have a fixed number of water molecules as an essential part of their crystal. These water molecules which form the part of the crystal are called water of crystallization, and such salts are called hydrated salts. For example, in your laboratory, the blue-colored copper sulfate is copper sulfate pentahydrate. When heated, this salt loses its water molecules and its blue color. Let us perform a simple experiment to verify the presence of water molecules in copper sulfate. Take some powdered copper sulfate in a test tube. Hold the test tube with a pair of tongs and heat it using a Bunsen burner. Observe that the blue-colored copper sulfate turns white. When this powder is moistened with water, the blue color reappears.
Do all salts have water molecules in their crystals?
Not all. Only some salts have water molecules in their crystals. For example, sodium carbonate decahydrate, Na2CO3 10H2O. Ferrous sulfate heptahydrate, FeSO4 7H2O. Zinc sulfate heptahydrate, ZnSO4 7H2O. Magnesium sulfate heptahydrate, or Epsom salt, MgSO4 7H2O. Potash alum is a sulfate of potassium and aluminium with 24 water molecules, K2SO4 Al2 SO43 24H2O.
Poor boy! He's hurt himself, and his arm is in a cast.
Do you know what that cast is made of?
No?
It is made of plaster of Paris. Gypsum, when heated to 100 degrees centigrade, forms plaster of Paris, which is chemically called calcium sulfate hemihydrate, CaSO4 half H2O. This calcium sulfate hemihydrate, CaSO4 half H2O, sets, and becomes a hard mass when mixed with water. Some of the uses of plaster of Paris are for setting fractures, since it hardens when mixed with water and sets in a short time, as a fire and waterproofing material, as a sealing agent in the laboratory for sealing air gaps in apparatus where airtight arrangement is required, for making casts for statues, toys, and decorative articles, for smoothing wall surfaces,